All right. I will pass out to you guys the units at a glance so you can check mark what we're doing. This is 1.1, 1.2, 1.3. You already know this. Relax. So it says here, let's start with limits. What is the limit? What does it mean to find a limit? Let's start with notation and go from there. The notation for a limit will look like as x approaches c of f of x equals L. Relax, is not that bad. This is read as the limit of f as x approaches c is equal to L. If you want to call the function f of x, then you could also say the limit of f of x as x approaches c equals L. Basically, informally, a limit is a y value, which is which a function approaches as x approaches some value. You guys remember that from last year? Okay, and then you guys can read that if you want. That little minus sign means from the left. That little plus sign in the upper right-hand corner means from the right, from right. So hopefully you guys remember this from pre-cal. And then it says the graph to the right, and it's the same function that we used last year. The coordinates of the hole is negative 3, 7, 6. That comes from somewhere. And then the dashed line of the vertical asymptote, but x equals 3. All right, so let's talk about where it comes from. So I'm going to just write this function. F of x equals 2x squared plus 5x minus 3 over x squared minus 9. The denominator is called the difference of squares. We should be able to do that really fast, right? Difference of squares, x plus 3, x minus 3. And then the top is factorable. There's only two numbers that when you multiply give you 2x squared, 2x and x. And there's only two numbers that when you multiply give you 3, 1 and 3. But where do they go? Well, the 3 is going to go here and the 1's going to go there. Chop, why? 2x times 3, that's 6x. 1 times x, that's 1x. The difference between 6x and 1x is 5x. That's what I have in the middle. I want it to be positive, so that means that 2x times 3 has to be a positive there, right there. And I have to have this one as a minus. Does all that make sense to you guys? Okay. From there, notice that I have a common factor in the numerator and denominator. You see that x plus 3 there? That's what creates your hole. Hole at x equals negative 3. Wherever the x plus 3, wherever your factor zeroes out. So how do you find the y value of that hole? Insert negative 3 into whatever you have left. 2 times negative 3 minus 1 over negative 3 minus 3. And I'm going to put this in for good notes. To find y value of hole. 2 times negative 3 is negative 6. Minus 1 is negative 7. Negative 3 minus negative 3 is negative 6. Negative divided by a negative is a. And that's how we found our hole at negative 3, 7, 6. Does that make sense? Don't worry, guys. I know you guys were probably a little rusty. How do I find my vertical asymptote? Well, you can't divide by 0. So whatever factor you have left, wherever that zeroes out. This zeroes out at x equals 3. So that's how I find my vertical asymptote. What's up, Kyle? Hit me. Yes. You know how you can't divide by 0? Well, what makes my denominator 0? 3. So that means that x equals 3, you have a vertical asymptote. Yes, always use the denominator to find your vertical asymptote. If someone ever told you that you cannot cross horizontal asymptotes, that is a lie. You can. Depending on the situation. There's something called steady state, and it doesn't matter. Vertical asymptotes you never cross. Horizontal asymptotes you can. Are we okay, guys? Nothing crazy. All right, Math Life 24/7, where to go? All right, there we go, guys. Let's keep going. So that's how we found this. So let's see if you guys remember. So it says, here's my statement. As x approaches negative infinity, the graph of f of x. So this is f of x. As x approaches negative infinity, what does it look like that y value is approaching? It's approaching that blue dashed line, 2. So f of x is 2. How do I write that with limit notation? You write limit, Lim, as x approaches negative infinity of this function f of x equals 2. There it is. That's it. Are we feeling okay? All right. As x approaches positive infinity, the graph of f of x approaches. Well, what does it look like if I approach positive infinity? It looks like I'm approaching that blue dashed line again. So it's going to be approaching 2. That's because that's my end behavior. Limit as x approaches positive infinity of f of x equals 2. Are we okay so far, guys? All right. As x approaches negative 3 from the left, the graph of f of x approaches. Well, here's negative 3. That's my whole. Negative 3 comma 7, 6. So if I approach negative 3 from the left, I'm approaching that whole. So 7, 6. And you're going to write limit as x approaches negative 3 from the left. So put a little minus sign in the upper right-hand corner. F of x equals 7, 6. Anytime it says from the left, that's where you're putting that minus or plus sign in the upper right hand corner. That's did I hear it right or no? Did I answer your question? Okay. As x approaches negative 3 from the right, so I'm approaching negative 3 from the right, and I'm approaching that same y value. So 7, 6, and I go limit as x approaches negative 3 from the right, so put a little plus symbol of this function. You can also write the rational function, rational expression, but it's easier to just write f of x. Because the left, I'll slow down. Because if you approach from the left-hand side of as approaches negative 3 from the left, and it equals the same as limit as s approaches negative 3 from the right, because they're the same, 7, 6, I'm going to say limit as s approaches negative 3 of the graph of f of x equals 7, 6. And now if it did not equal the same number, what will we have said? DNE does not exist, but it does in this case, right? So we're just going to write limit as x approaches negative 3 of this function equals 7, 6. Perfect. Way to go, Miss Houston. You're winning. You see? You wanted to do limits today. I'll stop. I'm not a bully, am I, miss? I should have put the picture there. I'm sorry, guys. Next time I will. As x approaches 3 from the left, the graph of f of x. Okay, so let's look at this graph. Here's x equals 3. It's a vertical asymptote. If I approach from the left, I'm approaching negative infinity. So you can say limit as x approaches 3 from the left. So that's how you say the left with a little minus sign of this function equals negative infinity. Or you can say does not exist. Both are equivalent. That's an or. Yeah, you're not converging to any number. As x approaches 3 from the right, the graph of f of x, well, if I approach 3 from the right, what does it look like? Positive infinity. So I'm going to write positive infinity. Limit as x approaches 3 from the right of this function equals positive infinity or does not exist. We're still okay? Okay. As x approaches 3 from the graph, as x approaches 3, the graph of f of x, well, one behavior is negative infinity, the other behavior is positive infinity. So what's the best one to use? Does not exist. Perfect. If both behaviors were one-sided, like positive infinity or negative infinity, I would have said that, but does not exist instead of using the acronym. And that's all this is saying. That's all this one-sided and two-sided limit saying. As long as the left and the right match, you're going to say whatever that limit is. And if they don't match, then you're going to say it does not exist. Cool or not cool? Okay, all right. Look, guys, this is the same notes from last year, so hopefully you find this kind of. Do you guys find this kind of easy or is kind of difficult? Okay, yeah, and don't worry, we'll be done real quick, guys. All right, limit as x approaches negative 1 from the right. So if I approach negative 1 from the right, what is that limit? 1. There it is. Limit. I'm looking at letter B. Limit as how do I read that? By the way, how do I read that, Miss Kyle? Yep. Yeah, limit as x approaches 1 from the left of f of x is, what is that limit? Not 1. Nope, I'm approaching x equals 1 from the left, 2. Yes, when you look at x equals 1, see here's x equals 1. I'm approaching from the left, so go to the curve, and I'm approaching from the left. So there it is, I'm approaching from the left. So
because technically if it's a whole y,
I'm just doing limit. I'm not doing the function evaluated at 1. I'm just saying what am I converting to if I approach from the left. So if I were to say what type of 1, well, it's a whole. It's equal to 1. But limit is approaching 1 from the left. I'm just whatever I'm approaching. I don't care about whatever you're approaching. That's all.
Is it not 1 because there's not like a line?
What are you talking about? Hit me.
Say there wasn't a line between 1, 1 and 2, 1.
One, one. Oh, if there's a line like that, it just means it wouldn't be a function, right? Because it has to pass a vertical line test. Right now, it's a function. If I draw a vertical line wherever, it only crosses it once, no matter what.
Asking like, the line connected 1, 1 and 2,
1,
1.
1 and 2, 1. Oh yeah, this line.
If there was no line called,
Well, I'm still approaching from the left. So on the left, I still have a curve. Yeah, you know what I mean? All right, limit as x approaches 1 from the right. So now I'm looking for numbers larger than 1. If I approach 1 from the right, what is that value? 1. Do you guys see what we're doing? All right. Limit as x approaches 1 does not exist. Tell me why it does not exist.
it's not the same.
Because they're not the same. What's not the same? From the left and from the right. They have to be the same, guys.
Can you explain C again?
Yes. When you see how it has a plus symbol? So I'm looking at all the values to the right of 1. I'm going to approach 1 from the right. So if I approach 1 from the right, what is that y value that I'm converting to? Do you see what we're doing? Letter E, limit as x approaches 2. Well, if I approach from the left and the right, it looks like I'm just converging at 1. Limit as x approaches 3 from the left. Well, that's the only direction. If I approach 3 from the left, what's that y value? 1. Now, does this say the word limit? No, it just says, it's just an algebra question. What's f of 2? 2. It's that where it's defined. There it is. How do we feel, guys? All right, here we go. These are just sample questions I took. Let me go ahead and write the source of this graph. Do you guys recognize this graph? It's from Delta. That's the Delta's fonts. So I'm giving the source. So let's see. It says limit as x approaches 3 from the left. So I'm going to look at it 3. If I approach 3 from the left, what's that limit? 1. See? Limit as x approaches 3 from the right. If I approach 3 from the right, what's that limit, Rodriguez? 3. Limit as x approaches 3 does not exist. Does not exist. F of 3. Yeah, I put undefined for this. That's a better answer. You're right, it does not exist. But does not exist, that phrase is better for limits. Does that make sense? And then if it's not a limit, if it's a function and you see no values there at 3, you're going to say what?
But what about that curve, though? It's -3, -4. I mean, -4 and 3. Like, coordinates?
No, well, I'm looking at 3. It says f of 3. It's f of x equals y like that. So at some x coordinate, what's my y value? So this is telling me at 3. And I look at x equals 3 all throughout there. Look, I'm never defined.
Okay.
So for functions, you're going to use this word undefined, and for limits, you use does not exist. Hit me. Say it again. Oh, if one of them was, both can't be solid because then it wouldn't be a function. But if one of them was solid, you would say like if the 3, 1 was solid, you would say f of 3 equals 1. But it doesn't say that. It's a whole. Hit me, guys. Hit me. You got some more? All right, look, we're almost done, guys. We're almost done. We have this function. It says use the graph of the function shown below in order to determine all values a for which limit as x approaches a of f of x equals 0. Okay, so here's the easiest way to do it. So I'm going to go here on the side, and I'm going to say, what does it mean for f of x to be 0? That means I want my y value to be 0. Does that make sense? So I'm just going to, where is the y value 0? On the what axis? Not the y, on the x-axis, the y value is 0. So I just highlighted my x-axis as red, and I just look to see how many times my limit is 0. So my limit is 0 right there at -5. So I'm going to write limit as x approaches -5 of this function is 0. Let's see, where else? It looks like at 2. Limit as x approaches 2 of this function is 0. Where else? Be careful. At 7, yes, it's true, but only from one direction. What direction is that? From the left. So notice I put a little minus sign there, 0. And then I have another one, limit as x approaches 8 of f of x. That one is 0. And there it is. So what are my 3 answers? I know I put 4 of them in there. Now slow down. Let me slow down. My three answers are this one, and this one. I want it from both directions. So I'm going to say, so my A, look what it says. It says X approaches A. So my A's are -5, 2, and 8. You can do it. If you don't like the comma, you can say A equals -5, A equals 2, A equals 8. Not a big deal. Does that make sense to you guys? Hit me.
Can you explain why we didn't do the 7?
Oh yeah, because the 7 doesn't work for the right hand side. See how there's no plus or minus on the 8? So from the right hand side, like it's 2, but I need it to be a 0. So I need it to go from both directions. Hit me, Lauren Johnson.
I have the same
Oh.
question.
Yeah, guys, these are good questions. What else? We got it? Are we math lifing? Okay. Are you happy? All right. Look, last page. Look, we're already done, guys. Sketch a graph. I think that's you guys are visual learners, so don't worry. It's easy to do the graph. You guys just gave me an ugly look to sketch the graph. Okay, look how easy it is. These are all linear lines or points. -x plus 1, y-intercept at 1. So I'm going to put a 1 here. I'm going to say that's 1. And my slope is 1, -1. So at 1, I'm at 0. So, and it's a hole because there's not an equal sign there. So I'm going to say this is 1 and it's whole. And then here is that one in red. So this one, look, I'm going to circle it. I'm going to color code it. That one's in red. Do you guys see what I did there? All right, let me go to green. I'm going to do this one in green. Between 1 and 2, it is always just 1. That's a piecewise function. At 1, it has an equal sign. So I'm going to say here's 2. I'm saying no, 1. It's 1. So here's 1 solid circle. And I'm going to go all the way to 2. And at 2, I'm going to put an open circle. Do you guys see what I did? Ask me questions, guys. Rodriguez, hit me.
No.
Okay. All right, this is just a point. It just says 2, 2. That just means when x is 2, the y value is 2. So I'm going to go to 2, 2, and I'm going to put a point. 2, 2. Let's see, what other color have I not used? I'm gonna use burnt orange. Do we have any Longhorns here? All right, here it is. For you Longhorns, burnt orange. Chubb, I don't know how to do that one. Plug in a 2. 2 minus 1 is 1, but put a hole there. So 2, 1, I'm right here. And then at 3, 3 minus 1 is 2. So I'm going to go to 3. And I'm going to go put a point, a solid at 2. And I'm going to connect those two dots, the hole with the point. There it is. I just plugged in a 2 in here for x. 2 minus 1 is 1, so I don't have a hole at 2, 1. And then I plugged in a 3 in here. 3 minus 1 is 2. So I don't have a point at 3, 2. And I know it's a linear line, so I just... Oh, yeah, keep hitting me, guys. Keep hitting me. Oh, because I have a linear expression, x minus 1. You know what I mean? I haven't used blue. Let me go to blue. Here we go. So I know, again, I have a linear expression, -x plus 5. I'm going to plug in a 3. -3 plus 5 is 2. So I'm going to go to 3, 2. And I know that's a hole, but it's already covered with the burnt orange one. So it's not a big deal if you fill it in if you want. But to be technically correct, I'll put a hole in there at 3, 4 with the blue line. And then if I plug in a 4, 4 minus 5, -4 plus 5 is 1. So I'm going to say here's 4. And then there's 1, and then solid. And then connect those two. And there it is. How do we feel, guys? All right, so here we go. Ready? This question here, it says limit. Oh, hit me. Got it? Oh, yeah, no, hit me. All right, we're going to go down the table like this. Is that okay? And no pressure. This is no pressure. If you get it wrong, it's not a big deal. I promise. I do not judge. I hope you guys know that. Well, I do judge, but not in math. I don't judge you guys. Guys, I love you guys. You guys are all, yeah. I do not judge you guys. This is your first rodeo. It is your first rodeo. So we're gonna go left to right. All right, Ms. Vega, can you read this expression for me, and then tell me what the answer is? No, say the word limit first. Yeah, limit, yeah. Limit as x approaches 0. Yes. So limit as x approaches 0 from the right of f of x is 1. Perfect. All right, Zamora Johnson, can you hook me up with this one?
As the limit approaches x, or as the limit approaches going from the left, f of x equals 1.
No, not 1.
No, 1. Sorry.
No, not 1. It's okay, miss. Don't worry. Look, so check it out. I'll help you out. So limit as x approaches 1 from the left. You said it perfect. So I'm going to limit this curve. If I approach 1 from the left, what's the y value?
0.
There it is. Yay, we got it. All right, Esquivel, hook me up with this one right here.
Limit as x approaches going from the right.
Perfect. Say it loud and proud, miss. You got this. All right, Mia Berry, hook me up with this one.
Limit as x approaches 1 does not exist.
Perfect. Why does it not exist?
From both sides.
Because they're different from both sides. From the left it's 0, from the right it's 1, so it does not exist. All right, Gonzaga, hook me up with the next one. Perfect. Good job. Deenan.
Limit as x approaches 2 from the right.
Is what? Yes. I didn't hear you, miss. Sorry if you were waiting. All right, let's see who's next. De Leon.
The limit as x approaches 2 is 1.
Perfect. Cruz.
The limit as x approaches 3 from the left is 2.
Perfect. Kyle.
The limit of x from 3 to the right.
As x approaches 3 from the right.
3 from the right is 2.
Perfect. Rodriguez.
The limit as x approaches 3 f equals 2.
Perfect. Houston. Sorry.
The limit as 4 approaches x approaches 4 from the left, y
Is 1. Yeah, sorry. All right, let's see. Morales. Does this say the word limit? All right, so what is f of 2? Good job. It's a function. Just evaluate it at 2. There it is. What's up?
So, if we say from the left, then you know when they draw arrows, so the arrows
Yeah.
literally the left side of.
You're to the left of 2. Or to the left. If you say limit as x approaches 2 from the left,
It's
to the left.
in the direction it's
yeah, and then you're approaching 2. Yeah, good job, guys. All right, here we go. I guess yeah. Well, let me take out the QR code so you can register really fast. I'm gonna try to do this. I think it's gonna work. We'll see. Do you want to scan that QR code and see if you guys can answer this question? At the very minimum, go ahead and make an account on Poll Everywhere. There's an app that you can download if you want to download it. All right, here we go. Let's see how we did. Responses. I don't think I'll say names. I think I'll just have the answers. Why are they being so slow? I don't know why it's being slow like that. Okay, well, let's see. I'm gonna exit it. I don't know why it's being slow like that, but maybe I gotta tune it. So here's how I would do it, guys. Like I said, maybe you guys are visual learners. So does everyone know how x squared plus 1 looks like? X squared plus 1 looks like this. It has a vertex at the 1 on the y-axis. It's just x squared with a vertical translation of up 1. But this says it only behaves like that between -2 and 2. So here's my grid. So I'm going to write, there's my grid. I'm going to say here's -2. I'm going to say here's 2. And -2 squared is 4. 4 plus 1 is 5. So I'm going to say here's 1. And I'm going to say here's 5. And that's an open circle. I mean, that's a closed circle. I guess let me go ahead and write it like this. Closed circle. And at 2, it's an open circle. So it looks like this.
Also, all that tells us is like how to graph it.
Well, because it's in pieces, right? Like it's so I'm gonna graph x squared plus 1 between -2 and 2, and then right at x equals 2, the y value is 1. So at 2, I'm gonna put a point right there. And between 2 and 8, I just behave like 5. So I'm gonna say not to scale. I'm gonna say here's 8. So I'm gonna go and open circle like that, and there it is. So that's just the graph. That's just from this, right? So some of you that answered 5, I think you got the answer correct. So what's my limit? So I'm going to write limit as x approaches 2 of this function f of x. So if I approach 2 from the left, so here it is, I'm coming to 2 from the left, the answer is 5. If I approach 2 from the right, the answer is also 5. So that's my limit. Now, if I would have told you, they didn't tell you because they said limit, right? But if they would have said, what is f of 2? Notice there's no limit in the front. So if they told you f of 2, you would say 1. Does that make sense, guys? All right, guys, I think we're good. Only 3 of you have created AP Classroom accounts and Delta accounts. So let's go ahead and do that. So how do we do that? Log into Delta Math. Log into Canvas.